Hi, this is Jonathan Sarayan, doing an individual presentation for Afghan Trail, our project in CIT 260, Section 7. Static and non-static class variables. So static, you have a few properties, so that they're shared across all instances of the class. The value is independent of the objects. The class can be accessed without instantiating an object, and it should be accessed by using the class. This is just to prevent confusion. If you access it by the instance, which can be done, it'll look like it's a not a static value or not a static member variable, and when it is. So you want to be clear, and also static methods cannot be overwritten, and that's because they are resolved at compile time. Non-static values are more straightforward. The value that they hold is specific to that instance, that object, and they can only be referenced by the instance. You can't reference them through the class name. And changing a class instance variable will not affect variables of other instances. Alright, so here we have an example of a static method inside of the being attacked class. So the fight back is made into a static method by using the static keyword. Here we have a static variable, which is just a string. In either case, they would be accessed using the class name, and they wouldn't be accessed using an instantiation of an object of the class being attacked. In fact, we don't have any member variables or member methods that are not static in this class, so there wouldn't really be a reason to instantiate an object of the type being attacked. We can see where these are used, the implementation. Here in the being attacked view, we have the fightback method being called, passing the player as a parameter, and you can see that it's accessed via the class name rather than an instantiated object. And to see an example of a non-static method in a class, here we have the being attacked view again that inherits the display method from basic view, which it extends. This display method is not static. So it's a non-static method that you won't see here, but it is part of this class. And we actually we instantiate a being attacked view object here, which calls its constructor. Here we have our object, and here we're calling the display method on that object. And this you can do because it is a non-static method display. You can do this with static methods as well, but it gets kind of confusing, so it's better to only call static methods using the class name like we saw earlier. Here we have some containers in Java, list containers, array list, array, and enum, each of which has different properties and benefits over the other. Array lists are of variable length, contain object elements. You can change the data types, or you can have different kinds of data types within them, and they're indexed using an offset starting at 0 and going to 1 less than the length of the array list. It's the same with the arrays, but they are of a fixed length. You can't add or remove from the arrays. You can store primitive or object elements in them, and the elements have to be of the same type. But they are modifiable, so you can access them and then change the one that's indexed in where you're accessing. Enums are of a fixed length, and they're constant elements. This is the most solid of the containers. You reference it by name, whereas the other ones you're referencing by index. I'll show you a few examples in the code. Here we have our enum, which is implementing this father object. Here are the details for it, and again, this wouldn't be able to be changed by any code outside of this implementation. Here we have a string array. It's actually two-dimensional. It's an array of arrays, and we chose to do this because we won't be adding any more item types. These are just the names of the items. Where we're actually storing items is in an array list inside of this inventory class. The array list is of the type item, so you're going to be putting a lot of item objects inside this array list, and it can grow and shrink according to how the game plays out for the player. Alright, here we have an array list. It's going to be filled with a number of items that we are getting from the shopkeeper inventory, which we're getting from the shopkeeper's get player inventory method here. And we're going to be asking the user to choose an item to buy from this list, and we're going to loop through the shopkeeper's items to then find out what the user's choice is. And I'll actually go back to our output here, and I'll choose the euro 3. And here we're seeing that the index, the integer I, is obviously starting at 0 here in this portion of the for loop. And when this expression evaluates to false, then our loop will stop. Until then, it'll run everything in this block, and each time after it runs, it will increment our index. So right now our I is at 2. Our user choice was 3. So 3 minus 1, 2. This should evaluate to true. And if that's the case, we step into this block here. The shopkeeper item will get the index. So we'll get this one here, and it'll get put into, right there it was null, and now it's the euro, you can see there. And there we have our output there. So that's how you loop through a array list. Throughout the game, we have a number of custom exceptions that can be thrown. Most of the time, they're thrown in the controllers. Here's an example of one that I wrote. Being attacked exception. All of these exceptions inherit or extend the Java exception class. Here we have a few custom designed constructors. That way, when we throw them, we can pass a string or a throwable, just a throwable, string, a throwable, and 2 different booleans that would then get passed to the super or the base class's constructor. Now, the way these are used is in our constructor, and I'll actually show you the view first. Here we have this method being called right here, and you can see it's wrapped in a try, so you know that either of these statements, or at least one of these statements, has the potential to throw an error. We're going to be looking at the being attacked fight back method here, which does indeed say that it can throw a being attacked exception, which is our custom exception. And here it throws it if the stamina, the player's stamina, is larger than 100 or less than 100. It'll say invalid stamina and throw that error. That error is propagated up back to where it is called, to this try, and control is given to the catch statement that is going to handle the being attacked exception. We have another catch statement which handles number format exceptions in a different way. Alright, now I'm going to tell you about the character streams. Here we have a few examples of character streams with their class names and their descriptions. You can see by the names they're appropriately named for their purpose. And Java actually recommends using character streams, and I'll tell you why. So there's 2 character sets, ASCII and Unicode, that are widely used. ASCII supports English, and it's stored in memory as one byte per character, where Unicode is 2 bytes per character, and a byte stream handles 1 byte at a time. So you can see there it's not going to be able to handle Unicode, which is 2 bytes for each character. So that's why Java recommends using a character stream, because it can just handle the size of Unicode, and then you're able to stream and handle more languages than just English. So you're able to receive from the keyboard more languages, Unicode, and you're also able to put out to the screen from your program more languages than just English through Unicode and through character streams. Here in the game menu view, the player is given the option to print their inventory to the screen, and if they choose that, they're prompted to input a file name where they want the player inventory to be printed, and that file name is then passed to our log inventory function along with the game object. That way we can have access to the player and therefore the player's inventory. And this we store in an array list that we can later iterate over to build the string that we will be putting out through this file writer and buffered writer. And we'll be putting those into the file that's been passed. So they start out as null from the get, so that when we do the actual instantiating using the new, and anytime you see this new, there's a possibility that an error will be thrown because we're dealing with memory in these parts. And if ever there's memory not sufficient to actually instantiate this file writer object or buffered writer object, then we will pass control back to a catch, and there will be an IO exception, and that will be logged out to the screen, and hopefully in a graceful manner. If all goes well, we get our file writer, which we pass to the buffered writer, and now we have our out object buffered writer that we can use to print out to this file the player inventory. So we're setting up the display. Here we have our output string, some formatting going on just to show the name, the type, the price of each of the inventory items. And here we're looping through using an item. Here we're not using an index. This is a different way to loop through an array list. And we're doing some formatting to each item as well, and just adding these pieces that we're building to the output string. And here is actually where our write method is called on the buffer reader object, the buffered writer object in this case. And we're passing, of course, the output string. And here we actually added some extra code. We got this runtime instance, and we're calling an execute method on this runtime instance to our notepad program, which this is the default location for it in Windows, and we're adding to it our file name. And what this will do is it'll actually open up the file that we just wrote to. Alright, we're gonna start a new game here so you can see how it begins. And we'll talk to a shopkeeper. And let's try robbing him right off the bat. And it asks us how many items do we think we can take. Let's try a low level. The more items you try to take, higher risk. Oh, we did get a euro. Let's try keeping taking things. We'll try 2 now. And we did get 2. I think we better play it safe. Let that on. We'll leave town. Continue. And we'll ignore. Oh, we couldn't have done that. We're falling sick. Let's log our stats. Take a look at that. Here it shows up. Yeah, we're sick. And our chances of moving forward are still 90%. Let's take our medicine this time. And we're still sick. And the medicine didn't really help. Too bad. Let's talk to our shopkeeper and let's try robbing him again. Last time let's try 4. Oh, we were incarcerated. We lost the game. Oh well, can't win them all. Thank you for watching.